What if the odds change? Let's say the probability of the event, a winning ticket, goes from 1 in 2 to 1 in 4, but the consequences stay the same. So we change this to a 0.25. Our consequences stay at $2. Now what's the expected value of a ticket? Now the expected value of the ticket is 0.25, the probability, times the payoff, $2, which is only 50 cents, half a dollar. So at the start of that game, you can see that your ticket's going to cost you $1 each, and each one's going to, it's expected to bring you, that's the expected value, each ticket is expected to bring you 50 cents. So at the very start, you can see it's a losing proposition. Over a long period of time, you expect to lose money. Now, does that mean you will lose money? No. You may come out ahead, but you can expect not to. That's what expected value does for you. If you're there for a good time and you can spare the cash, go for it. Have the fun. But if you're betting with your retirement, this game wouldn't be a very wise choice. So what the expected value does for you is at the beginning of an endeavor, if you can figure out the probabilities and the consequences of those probabilities, at the start you can calculate in a very simple and realistic way what do you expect to get from a particular course of action. In this case, buying a ticket or not buying a ticket. That's how this becomes useful in climate change. We can get a sense of probabilities, we can get a sense of consequences, we can use the expected value to get an idea of what would we expect the value to be of choosing column A or column B. That's how we'll use it. Before we apply this to the climate change grid, I want to be clear on something. Some critics of my older video kept shouting, "But that's just a prediction," all caps, as if that means it's pure conjecture. Predictions are not statements about something that will happen, but that something might happen, and the better the prediction, the more robust the work that went into it, the more likely it will turn out to be a true prediction. For instance, if I'm betting on a roll of a pair of dice with all payoffs being equal, I'm going to bet on the 7, because my study of past dice rolls predicts that a 7 is the most likely outcome. But betting on a 7 doesn't require that I believe it will happen. Saying I predict that 7 is most likely doesn't mean I believe it will happen. It just means that based on my study, it's my best bet. Its expected value is the highest of my choices. And before you go crying, "But the expected value is a flawed mechanism, what about the St Petersburg Paradox?" I'll just make the point that if it's good enough to turn a profit for casinos and insurance companies, it's good enough for our purposes here. We don't have to go down the rabbit hole of mathematical theory. So to use this device of expected value for our grid about action on climate change, we need to get some sense of the probability of the two rows and the consequences of the scenarios in each box. But with the Google here to serve up statements supporting pretty much any conclusion we want, how do we sift through all the noise to come up with a confident assessment of probabilities and consequences? The problem is you can read Michael Crichton's State of Fear and then Fred Pierce's With Speed and Violence, Why Scientists Fear Tipping Points in Climate Change. You can look up the Leipzig Declaration and then the Scientist's Warning to Humanity. But at the end of the day, you'll still be left with the question, but they all contradict each other, so who's right? I know it sounds like I'm making the point that it's futile to do any research, but I'm not. I'm trying to make the point that if you want to get anywhere, you can't just read stuff. You've got to do things differently. To examine the source, to look at credentials and possible bias, to take a step back and ask not, who should I believe, but instead, what is the process I will use to decide what to go on? I'd suggest doing it by assigning weight to different statements based on the credibility of the source. As a science teacher, I've spent a lot of my time thinking about how you evaluate claims and assign credibility to sources. That doesn't answer the question, what should I believe, but it does provide an answer to the question, given the uncertainty, what is probably the most useful statement to move forward with? Which really is the fundamental question we're faced with at the heart of most matters. As a disclaimer, I'll point out that these are just general guidelines. Any source could be wrong, and as a colleague of mine is fond of saying, even a blind squirrel finds a nut occasionally. So this is a tool to just use as a starting point. I would place sources on a spectrum running from less reliable or less credible to more reliable or more credible based on two factors. One factor is, does the source know what they're doing? Let's call that expertise. Does the source know what they're doing? Are they trained? Are they speaking within their expertise? Are they conscientious? In other words, how likely are they to arrive at a correct conclusion? The other factor is, how likely are they to spin that conclusion? Let's call that bias. Do they have an agenda of some sort? What's the likelihood that they are biased in some way that will affect what they choose to tell me and what they don't? Using those two factors, I'd say that at the very bottom of our spectrum lies the individual layperson, who doesn't necessarily have expertise and may very well have an agenda. That's not to say there's nothing to be learned from individuals, though. They can be useful for new ways to see things or directions to go. It's just that you don't want to rely on their information any more than is necessary. Like Reagan said, check out what they have to say for yourself. I would give more weight to the individual professional who is speaking in their area of expertise, because they may have an agenda, but at least they know what they're doing. I might give still more weight to think tanks and advocacy groups like the Cato Institute or Greenpeace. They definitely have an agenda, but at least they're larger than the individual, so they have more resources at their disposal and hopefully their expertise is greater. For example, I found an interesting figure about atmospheric carbon dioxide that I wanted to use. So before throwing it into the video script, I looked at who provided it, and I saw it was someone with a PhD after his name. Well, that's better than nothing. From the Environmental Defense Fund. Well, not quite as credible as I'd like. Their agenda is right there in their name. So what do? I go look for that figure somewhere else, because I'm looking for the truth and not just support for my beliefs. Now this next one, I'm not sure where to put. Floating around the middle somewhere, I guess. Petitions and other self-selecting things. Like the Oregon Petition or the Economist Statement on Climate Change. They may very well know what they're doing. You should check to see that the signers have expertise in the area that they're signing about. But the problem is that the signers are self-selected. So by definition, there are no dissenters in there, so their spin factor can be fairly high. They are really susceptible to the trap of confirmation bias that I described in the video Nature of Science, though they can be pretty credible as well. For example, the Oregon Petition was a project of a small think tank of 6 employees in rural Oregon, while the Economist Statement on Climate Change had 6 Nobel laureates sign it. So I wouldn't give equal weight to the two, even though they both fall into the same category somewhere here in the middle. Again, it depends a lot on who the signers are. Somewhere in here, I'd put university research programs. I'm not sure where, so I'll just stick it off to the side. They're generally more credible than think tanks because they're a couple of funding steps removed from vested interests. Now we're getting into the pretty credible stuff, peer-reviewed science articles. As I noted in the video Nature of Science, this is getting close to the best that science can offer, because it's gone through a bruising process of critique by experts in the field and only gets published in the journal in question if it feels it's up to snuff. Now, some journals are higher quality than others, and their publications can be weighted more. There are a ton out there, and you can't be expected to recognize them, but I'll throw a few names out so that you can recognize them as being the gold standard if you see them. For instance, anything from Science, Nature, the Proceedings of the National Academy of Sciences, or Physical Review Letters is going to be literally the best you can get in science. Those journals generally don't publish an article unless they believe it marks a significant breakthrough in the field. So those are essentially the best you're going to get from science. You don't get anything more credible than an article that's published in one of those journals. I just recently discovered a danger in this rule of thumb about trusting the peer-reviewed stuff, though, that you should be aware of if you're going to be analyzing sources. Usually when someone gives me a reference to back up what they're saying, my first question is it peer-reviewed? And generally the stuff that's skeptical of human-caused global climate change hasn't been published in a peer-reviewed journal because it generally doesn't fit the expectations of rigor that most peer-reviewed journals maintain. But I recently learned there is now a small journal named Energy and Environment, which I've read that most scientists don't take seriously, but which does have its own peer-review process. The upshot is, and the editors admit it, it functions as an outlet for climate skeptics to get their stuff published so that the others in the political and popular debate can cite peer-reviewed scientific studies that show global warming isn't such a big deal after all. I find that scary. It seems like an abuse of trust because scientists know which journals are more reputable than others, so they know how much weight to give the publications they find in different journals, but the public doesn't. To us, if it's peer-reviewed, it's all the same. It must be solid stuff. That used to be true. Thankfully, it still is for the most part. Now here we get to the two types of sources that I think carry the most weight, and I don't think I'd rank one above the other. Here you'd put statements from an organization that contradict its normal bias. For instance, if the local timber lobby says, we've got to thin out this forest for its own health, you wouldn't be that convinced. But if the Sierra Club made the same statement, that we've got to cut down that forest to save it, then you'd sit up and take notice. The reasons must be really compelling if the Sierra Club is going to contradict their normal message. Finally,